Alright, so we left off here at 1 times 2 over the square root of 3 where we had flipped that bottom piece of the fraction. And so this is just going to leave me with 2 over square root of 3. And then I'm going to have to rationalize this. So I'm going to multiply by square root of 3 over square root of 3. And so then that's just going to end up giving me 2 square root of 3 over square root of 3 times square root of 3 would be the square root of 9. And the square root of 9 is just 3. So it's kind of like you can think about these square roots just kind of cancel out and go away. So the cosecant there is just 2 square root of 3 over 3. Now, we have to do the secant. So the secant of 2 pi over 3 is just going to be, secant goes with cosine, and cos goes with x. So that's just 1 over the x. So 1 over negative 1/2. So I'm going to take this and flip it, and I'll have 1 times 2 over negative 1. And so when I do this, 1 times that is not going to change it. So 2 over negative 1 would just be negative 2. And then the tangent, or the cotangent, at 2 pi over 3, would just be the x over the y. And so I would do the x, which is negative 1/2, over the square root of 3 over 2. And so then I would end up having to, this is one of those double deckers, so we have to flip that bottom fraction and multiply it by the top. So I'm just going to bring it up here and multiply by 2 over the square root of 3. Now the 2's cancel out, and I'm left with negative 1 over the square root of 3. And so I can't leave it like that, I got to rationalize. And so when I rationalize, this is going to end up being negative square root of 3 over 3. Alright, and so then those are our 6 functions of this angle. Alright, we're going to do one more, and this one's a little bit easier, and then I'll let you try some. So, at pi is here, and so the coordinate that I'm going to be using is negative 1, 0, so I'm just going to go write that down. And so when I'm looking for the sine at pi, that's just going to be the y coordinate, so that's just 0. When I'm finding the cosine of pi, that's just going to be the x coordinate, so that's just negative 1. And then the tangent at pi is just going to be y over the x, which is just 0 over negative 1, so 0. Alright, for the other 3, the cosecant at pi is just going to be 1 over the y. So 1 over the y would be 1 over 0. And if we have 0 in the denominator, that's going to be undefined. So I'm just going to abbreviate and say that's undefined. The secant at pi is just going to be 1 over the x. So that's just going to be negative 1. And then the cotangent at pi would just be the x over the y, which would just be the negative 1 over 0. And so the cotangent would also be undefined. And so then those are our 6 functions for pi. So if you have an angle that's on a quadrant, or one of those quadrant angles, it's a lot easier to evaluate. Alright, so you need to try these 4. And so I'm going to go ahead and just write the answers up, and you can try them. This should be negative square root of 2 over 2. This will be negative square root of 3 over 2. This will be negative square root of 3 over 3. And this will be negative 1. So you need to try these and make sure that you can get these when you evaluate them. Now, the next kind of angle that we're going to look at are negative angles. And so to evaluate a negative angle, you've got to get the angle that's in here to look like an angle on the unit circle. So if you have negative 5 pi over 4, that's not on the unit circle. And so we need to find a way to make this an angle on the unit circle. And so the way that you're going to do that, I took this over here to graph it so you can kind of see what you need to do. But an angle on the unit circle, this is a negative angle, so I went down and around this way. All I really have to do is find this angle right here that's a positive angle. And so the way I do that is I take negative 5 pi over 4, and if I add a full rotation to this angle, so if I go all the way around, I'm going to end up at the same place. It'll just be at a different angle measure. And so to add a full rotation, I would add 2 pi. And so in order to add that, I need to get a common denominator. So the denominator here would need to be a 4, and that would mean I also need to times the top by 4. So it's really like I've got negative 5 pi over 4 plus 8 pi over 4. And so the angle is just going to be the sine of negative 5 plus 8 is 3 pi over 4. And so then I would go do that exactly like I would normally. And so I'm going to look on my unit circle at 3 pi over 4. So let's go back over here. So unit circle at 3 pi over 4, and I was finding the sine. So sine is a y, and so that's just square root of 2 over 2. And so this is just going to be square root of 2 over 2. Alright, so then now we're doing cosine of negative 5 pi over 6. So I'm going to do the exact same thing first with the angle. So negative 5 pi over 6 plus 2 pi. And I'm going to get a common denominator. So I'm going to put a 6 in the bottom. And if I times the top by 6, 2 times 6 would just be 12. So you can always check this, because if you reduce 12 over 6, that's just going to be 2. So this is like you're adding 2 pi. So this is going to end up being 7 pi over 6. So it's really like we're finding the cosine of 7 pi over 6. And if you'll reference your unit circle, the cosine at 7 pi over 6 is the x coordinate, cos x at 7 pi over 6. And so that's just going to end up being negative square root of 3 over 2. Alright, cotangent at negative 4 pi over 3. Again, I'm going to take negative 4 pi over 3 and add 2 pi to it. And so I'm going to get a common denominator. This is just going to be a 3 in the bottom. 2 times 3 would make this a 6 in the top. I'm just going to write over it. And so then negative 4 plus 6 would be a positive 2. So I'm really finding the cotangent of 2 pi over 3. So at 2 pi over 3, if you look at your unit circle, this is your point. Negative 1/2 square root of 3 over 2. And so if we're doing the cotangent, that's just x over y. And so you would do negative 1/2 over square root of 3 over 2. And so this is one where I'm going to have to take and flip that and multiply. So this is just going to be negative 1/2 times 2 over the square root of 3. And so just like we did a minute ago, when we simplify this, the 2's are going to cancel, and I'll have negative 1 over square root of 3. Can't leave the square root in the bottom, so I'm going to rationalize, which is just going to give me negative square root of 3 over 3 as my answer. Alright, I think this is the last one, possibly, yes. So secant at negative pi, I'm going to take negative pi and add 2 pi. This one I don't have to get a common denominator. Negative pi plus 2 pi is just going to give me pi. So I'm finding the secant at pi. Now, if you go to the point on the unit circle at pi, that should be negative 1, 0. And so the secant is just 1 over, secant goes with cosine, so it would be 1 over the x. So 1 over negative 1 is just going to give me negative 1 for the secant at pi. Alright, so then those are how we evaluate negative angles. Now, we're going to look at angles that are not on the unit circle. We looked at negative angles. Now we're going to look at angles that are bigger than 2 pi. And so if you have an angle that's bigger than 2 pi, you're going to do the exact opposite of what you did whenever you had a negative angle. So if we had a negative angle just a second ago, we added 2 pi to that. And so now if you have an angle that is bigger than 2 pi, or not on the unit circle because it's too big, you're just going to subtract 2 pi. And so I'm going to get a common denominator. 2 times 6 is 12. And so this angle is really the same as pi over 6. And so I'm finding the cosecant at pi over 6. So that's just 1 over the y. And so our coordinate at pi over 6 is going to be square root of 3 over 2, 1/2. And so then when I simplify 1 over 1/2, I would flip this bottom 1/2. So that gives me 1 times 2 over 1, which is just going to be 2. Alright, we'll do a couple more of these. Tangent at 3 pi. 3 pi is bigger than 2 pi, so I'm just going to subtract 2 pi from it to get it back on the unit circle. So 3 pi minus 2 pi gives us pi. And so the tangent at pi is just going to be pi, the coordinate is -1, 0. And so that's just the y over the x. And so I'm going to put 0 over -1, which is just going to be 0. Alright. Secant at 23 pi over 6. So I'm going to take 23 pi over 6 and subtract 2 pi. And so get a common denominator. That'll be 6. This will be 12. And so 23 minus 12 is just going to be 11 pi over 6, and that's on our unit circle in the fourth quadrant. And so the point there at 11 pi over 6 is just going to be square root of 3 over 2, -1/2. And so I'm looking for the secant at 11 pi over 6. And so the secant at 11 pi over 6 is just going to be 1 over the x. So that's just 1 over square root of 3 over 2. Now, when I take and flip this and multiply, that's just going to give me 1 times 2 over the square root of 3. And so when I rationalize, I just get 2 square root of 3 over 3. Okay, last one. We've got 14 pi over 3. Now, on this one, when I subtract 2 pi, so get a common denominator, this will be 3, and 2 times 3 is 6. I'm going to erase this, rewrite it. So I've got 6 pi over 3. So 14 minus 6 is just going to give me 8 pi over 3. So now, that's an angle that's not on the unit circle. So this one is still bigger than 2 pi. And so what I'm going to do is subtract another 2 pi. So subtract another 6 pi over 3. 6 pi over 3. And so when I do that, that's going to end up giving me 2 pi over 3. And 2 pi over 3 is on the unit circle. And at 2 pi over 3, I'm going to have -1/2 square root of 3 over 2. So I'm finding the cosine at 2 pi over 3. So cos goes with x. And so this is just going to be -1/2 at 2 pi over 3. Alright, the last kind of angles that we're going to have are angles that are never going to be on the unit circle. And so when you have angles like this, you're going to need to use your calculator. And so let's go open our calculator. Alright, so I need to use my calculator. I opened my calculator up. And so the way that I'm going to do these is by typing these in just like they are, if they're sine, cosine, or tangent, because we have a button for those. If they're not, then I'm going to show you how we're going to go about doing these. But the way that I know this is never going to be on the unit circle is because if I look at the unit circle, this is pi over 5. And if I look at the unit circle, we'll go back here, and I look at all of these denominators, none of the denominators are ever 5. And so if you ever have a denominator that's not 6, 4, 3, or 2, that angle is never going to be on the unit circle no matter what you do. And so that's going to let you know I need to use the calculator. And so this pi over 5 is an angle that's in radians. And so I'm going to make sure my mode is in radian. And then to do the sine of pi over 5, I'm just going to type that in. So the sine of pi over 5 is just going to be 0.588. And I'm going to round that to 3 decimal places. So 0.588. Now, cotangent of -0.9. So if you look at your calculator, you don't have a button that is cotangent. And so we know that cotangent is the reciprocal of tangent. And so the way that I'm going to do this is I'm going to take where I have cotangent and put 1 over the tangent of -0.9. So I'm just going to make it its reciprocal function by putting 1 over it and changing the function to its reciprocal. This one was tangent. And so I'm going to type it in exactly like that. So 1 over tangent of -0.9. 1 over tangent -0.9. And so that is just going to be -0.794. Alright, third one, cosecant. 12 is never on the unit circle, and so I know that I'm going to have to use a calculator. Cosecant goes with sine, so I'm just going to use the reciprocal and do the sine of -7 pi over 12. So 1 over the sine of -7 pi over 12. I'm just going to type it in exactly like it is.